Okay, part D. The amount of coffee in the cup, the amount. So that's C of T. You just cross that off. It's better to get rid of words and go with symbols. C of T, yeah, we know it's ounces, is modeled by this formula. So now we have the fact that this table shows us measurements. It says they actually measured the coffee in the cup at different times. Then a mathematician or engineer or scientist took that data and created a mathematical formula that decently mimics the table. Doesn't mean it matches, it just follows it pretty close. It models the table. Using the model, so we've got to use B now. Find the rate, the word is rate, at which the amount of coffee in the cup. So we're finding the rate of change of the coffee in the cup. That means we're finding C prime at time equal 5. But we're doing it with this formula. So remember, we have one way of thinking of the amount as being C. You could also think of the amount as being B. They're asking us to find the rate at which B changes. We're finding B prime. So I want to just grab my calculator. Unfortunately, it's not a calculator problem. So I've got to find B prime without my calculator. So there it is. Not too difficult. The derivative of a constant would be 0. This is a multiplying constant, so I just wrote it down. So there's the 0. There's the multiplying constant. The derivative of e to something is e to that same something multiplied by the derivative of the something. So I'll clear that off again so you can see it better. So if you have the red box, 1 point. Then all you have to do is plug in a 5. So B prime of 5 is just plug it in, don't do any work, just stop. That gets you the second point, 2 total points available on this problem. The or here is just in case you kept going. You could have B prime as any of these forms. You don't have to have all 3, just any of those. You'd still get that green point.